In this case, we have given a single stage impulse turbine rotor which has a diameter of 1.2. So our diameter is 1.2 meter, d equals to 1.2, and running at 3000 rpm. So this is 3000 rpm. Nozzle angle is 18 degree, so alpha 1 equals to 18. Blade speed ratio is normally represented by rho, and is the ratio of blade velocity to the nozzle exit velocity, or we can say inlet velocity to the turbine, and is 0.42. The ratio of relative velocity at outlet to relative velocity at inlet, which is basically nothing but K, and K is the ratio of VR2 by VR1, which is given as 0.9. The outlet bed angle is 3 degree less, so beta 2 is equal to beta 1 minus 3, and the steam flow rate is given as 5 kg per second. We need to find out the axial thrust, blade angle, power develop, and blade efficiency. We can find out all this data once we know all the velocity component. So let's first compute what is the velocity u, that is a blade velocity, which is given by a product of pi dm into n by 60, and substituting this value of d and n, will get velocity equals to, the blade velocity equals to 188.5. Since we know the blade tip ratio u by v1, and we know the value of u, so we can compute the value of v1, 448.8. So we know u is equals to 188, v1 equals to 448, and alpha 1 equal to 18, and beta 2 is equal to b1 minus b3, and k equal to 0.9. So let's start construction of the velocity. So again, every time we have this standard triangle, that is a beta 1, beta 2 are blade angle, alpha 1 is nozzle angle, this is nozzle exit velocity. Then Vf1, Vw1 are the flow and velocity component of V1, and Vw2 and Vf2 are the components of V2 here, and this Vr1 and Vr2 are relative velocity. So this time I have selected a scale equal to 1 cm equal to 50, and u is 188.5, so we take a distance equals to AB, which represents 188 using a scale of 50, so that come out to be 3.8. Now this time I have already known the value of alpha 1, which is equals to 18 degrees, so let's construct alpha 1 equal to 18, and from ratio of tip we know the V1, which is 448, so approximately 9 cm. Now we can construct here one perpendicular and one horizontal from this line, so that we can finish up this part. So this total length from A to C is representing Vw1, and the C to D is representing Vf1, as represented by standard triangle. So Vf1 is come out to be 2.8, and Vw1 is come out to be 8.6. Now we'll try to find out Vr1. For this we have to join B and D, and we'll measure this length. So Vr1 is 5.6, and beta 1 is 26.7. Now I know the Vr2 is 0.56 times the K value, that is 0.9, and beta 2 is less than by 3 degree from inlet angle, so beta 2 will be around 23.7. So using these two data, beta 2 and Vr2, we can enter into the outlet triangle of the velocity. So at beta 2, which is the angle of ABE, so we construct here beta 2 equal to 23.7 at B, and we cut a distance equals to 5. Once we got the point E, we'll finish up with this right angle triangle, and therefore I will draw one perpendicular and one horizontal to get the point F, and we can record the value of Vw2, Vf2, and this one is V2. So Vw2 come out to be 0.8 centimeter using a scale of 50 meter per second, V2 is 2.2, and Vf2 is 2 centimeter. So using these standard values of beta 1 and beta 2, we get 26.7 and beta 2 equal to 23.3 degrees, that is blade inlet and blade outlet angles. As far as the blade efficiency is concerned, we have blade efficiency equals to 2 times of u Vw1 plus Vw2 divided by V1 square. All this distance will take as a cm, so that your u is 3.8, Vw1, Vw2 is 8.6, and other value is 0.8, is acting in the opposite side, that is why the sign is plus, and Vf1 is 9 square. So this, if you do this computation, we will get blade efficiency equals to 88.2. Remember that mass flow rate is given as 5, u is, we have converted into meter per second, this is 3.8 into 50 scale, that is 188.5. Vw1 is 8.6 multiplied by 50, that is 430, and this is 0.8 multiplied by 50, that equals to 40. So power developed will be approximately 442.9 kilowatts. And as far as the axial thrust is concerned, axial thrust is given by product of mass flow rate multiplied by Vf1 minus Vf2. Mass flow is 5, Vf2 is 2.8 multiplied by 50, which is approximately 140, and this one is 2 multiplied by 50, that is 100. So axial thrust is 200 Newton.